white die and two red dice are rolled, and what is the probability that the value of the white die is greater than both values found on the red die? Is greater than both values found on the red die, and what is the probability if the three red dice are rolled instead of two? So if the value of the white die is greater than both the values found on the red die, then in this case the possibilities are, if white die, and this is red dice, let's say this is dice 1 and this is dice 2. So white dice can have a roll of 1, but 1 will not be greater than any of the number, because the minimum number anyway is 1, so 1 is not acceptable. But white die can have 2, so that both of them will have 1. It can have 3, so that it can have either 1 or 2, and this can also have either 1 or 2. It can be 4, so this is 1, 2, or 3, and likewise this is 5, so this is 1, 2, 3, 4, and likewise. And this is 6, so this is 1, 2, 3, 4, and 5, and likewise. So these are the possible options. So the possible combinations are, the probability that it rolls a 2 is 1 over 6, and the probability that both of these roll a 1 is again 1 over 6 times 1 over 6, so that's 1, plus the probability that it rolls a 3 is again 1 over 6, and in fact all the probabilities, individual probabilities, are 1 over 6, and the probability that it rolls either 1 or 2 is 1 over 3, and the probability that this one rolls either 1 or 2 is also 1 over 3, and so on. We keep on adding this, so this will be now 1 over 2 times 1 over 2. This will be now a 4 over 6, which is 2 over 3 times 2 over 3, and finally this will be 5 over 6 times 5 over 6. So the total probability is coming as 1 over 6 is taken out, it's 1 over 6 square plus 2 over 6 square plus 3 over 6 square. uh, uh, I mean, that's the square is actually a complete square, so I should better rewrite it as like this, and so on till 5 over 6 whole square. Okay, so I think if we are interested in the fraction, then the denominator will be common factor, which is 6 square. This will be 1 square plus 2 square plus continue till 5 square. So we just grab my calculator and get this value. 1 square plus 2 square plus 3 square plus 4 square plus 5 square is 55, and 55 over 6 times 6 times 6 is 216. So this is the required probability of part A. For part B, there are 3 dice rolled instead of 2. So the only thing which is going to add up here is there will be a third die over here as well, and let me just do it with a different color. There will be a third die over here as well, which will mimic the first two dice. So it should have one, and can have one or two, then one or two or three, and so on. So the only difference is, instead of this square, we will have a cube, because that's how it's going to change. So the probability in part B is going to be 1 over 6 times 1 cube plus 2 cube plus so on till 5 cube over 6 cube over 6 cube. So again, let me just grab my calculator. That's 1 plus 8 plus 27 plus 64 plus 125 over 6 raised to 4. So this is coming as 225, and 6 raised to 4 is coming as 1296. Thank you.